Okay, so here's a balloon. Now I'm going to draw the wires. Okay. So we have two wires. One's making 58 exactly, sorry. So let's say that's about 58. And the other one is making an angle of 66. Okay, so I make it look kind of like that. And we know that we're given a distance between these two where the wires are held on the ground. It's 20 meters. And the balloon has a force of wanting to be lifted up, right, to float. That's called the buoyant force. So that force going up is 850 newtons. However, the balloon is not moving because the wires are negating this 850 newtons, both horizontally and vertically. If it was not negating horizontally, it'll move in one direction, left or right. If it's not negating the vector vertically, it will start lifting up, right? So the buoyant force only has vertical force, right? It doesn't have any side to side force. Okay. What that means, okay, so see this vector here, which is the sum of this vector plus that vector, and this vector here, which is the sum of this vector and that vector. These two must cancel each other out. Agreed? Those two must cancel each other out. And see the force of this. So this vector here, do you see that this one plus this one must add up to 850, so that it doesn't get lifted up. So let me call this one A, vector A, and this one B. This one here is AY, this one here is AX, okay? This is BY and BX. We know, first of all, the AX will equal to the magnitude of AX will equal to the magnitude of BY. So BX, that's condition 1. We know AX is just simply A, the magnitude of A. We need to find some angles here. This is given to be 58. So by the Z pattern, alternate angle, this is also 58. So we know that this AX is A times cosine of 58. And BX is B cosine of 66 for the same reason. This is 66. This is also 66. So we have two unknowns here. If you have two unknowns, how many equations do you need? Two. Okay. So the second condition, verbally we said, was the following. That AY plus BY is going to equal to 850. AY is A, right? It's going to be sine of 58. B, sine of 66. Okay. Let's isolate B. So B is A times by cosine of 58 divided by cosine of 66. Okay. So you plug that information into equation 2. Right, equation 2. So you get A sine of 58. This B will be replaced with another A. Right. Sine of 66, cosine of 58, cosine of 66. Okay, that's all equal to 850. And the 850 shouldn't have an angle there. Okay, so you just factor out A. And you know that it's going to be 850. You can times both sides by cosine of 66. So cosine of 66 and divide by okay, that'll give you the value, the magnitude of A. Okay, so we found the magnitude of A. So we can go back to this equation here, 1 prime. Let me use a different color, 1 prime. And from there we know that B is going to be 417.02 times by cosine of 58 divided by cosine of 66. Okay, so that's the force of the second vector B. That's a tension force. We call that a tension force on a tension of the wires. These two numbers make sense. They add up to like over 900, right? So you know it's not too big. So you can imagine how if they would they will hold down a force of 850 newtons, right?